Hi everyone, and thanks for joining. Today I'm going to walk you through this included very easy Linux box available on Hack the Box platform. This is the fifth box from Starting Point and Tier 2. Don't forget to contemplate the series of machines. It has tags, PHP, custom applications, protocols, Apache, TFTP, LXD, Reconnaissance, local file inclusion, clear text credentials, and arbitrary file upload. So we have an idea what to expect. We'll see and learn from this box. I'm already connected to Starting Point VPN network from my own attacker instance. These are my VPN configuration details. And let's proceed to spawn the target instance. While we are waiting to get the target IP's address here, I'll go through official write-up introduction, but then after that focus on hands-on part. And towards the end of the video, as usual, go through these task questions. Enumeration is always the key when it comes to penetration testing. The better the enumeration, the better the chances of finding and exploiting vulnerabilities. Most of the times you won't find a single vulnerability that will grant you access. Instead, it will be the chain of misconfiguration that only, if used together, will let you inside. This machine teaches some more enumeration techniques, even on a different transport layer protocol. And it also teaches that every penetration tester sometimes needs to use Google to see how to perform certain tasks. I'll first ping the machine as usual to see if it's responsive to ICMP echo requests, but that's not mandatory. Then I'll proceed to run nmap with switches SC, SV, which will scan for top 1000 TCP ports. And looking at the screenshot, we expect to see only port 80 for HTTP open. And we'll proceed to navigate to port 80 using a web browser. Great, the machine is responsive to ICMP requests. We see TTL63 is expected for a Linux instance here. Great, let's save ping and nmap output into a notes file. And immediately from nmap output, we see an interesting file parameter mentioned and home PHP. Let's navigate to this web page via browser. You can notice the URL automatically changed and added this file parameter equals home.php. And this is a common way that developers use to dynamically load pages in a website, and if not programmed correctly, it can often lead to a web page being vulnerable to local file inclusion. Dynamically loading pages is a good way to seamlessly load different web pages. Looking at this code snippet, how this dynamic page loading might work in the backend. If this include command is not restricted to just the web directory, for example, var www.html, it might be possible to abuse it in order to read any file that is available on the system, and the user who is running the web server has privileges to read. This is what is called a local file inclusion vulnerability, and we saw an example of it in one of the previous walkthroughs. Let's test it out in this case by replacing this home PHP part with etc passwd. I'll try it out first visually from the browser, then from the terminal. Great, and let's do this from the terminal. Great, and from this list we might observe a couple of interesting items such as root, www data, backup, LXD, mic, and TFTP. And while a local file inclusion is a great way to gather information and read system files, the goal of every penetration tester is to achieve remote code execution on a system. There is a plethora of ways that an LFI can turn into RCE, from log poisoning to plain text passwords in configuration files and forgotten backups. However, in this case, the passwd file gave us a big hint as how to proceed. Let's highlight the last user named TFTP. A quick Google search would reveal that TFTP, Trivial File Transfer Protocol, is a simple protocol that provides basic file transfer function with no user authentication. TFTP is intended for applications that do not need the sophisticated interactions that the file transfer protocol provides. It is also revealed that TFTP uses UDP, User Datagram Protocol, to communicate. And we'll proceed to use dedicated nmap switch-su to scan for open UDP ports. It is worth noting that a UDP scan takes considerably longer time to complete compared to a TCP scan, and it also requires superuser privileges. And let's quickly refer to our TCP and UDP port cheat sheet to the information about TFTP by default. Default port for TFTP is 69. So considering this UDP port scan takes a lot of time, I'll narrow it down to scan range of ports from 55 to 75. And after a while, I expect to see port 69 reported back as open. Keep in mind this switch is case sensitive. Then let's add target IP address and range of ports from 55 to 75 only for the sake of time. And let's see very verbose output. Great, this took less than 2 minutes. And as expected, there's port 69 open. And I'll proceed to verify if this TFTP command line tool is already available on my attacker machine. If not, I'll proceed to install it using this code line. Then check help and manual for TFTP. Let's try to auto-complete it, and it works. Get, put, quit. Okay, let's exit out from here. So we previously saw that the web server works with PHP files. We'll then proceed to try to upload the PHP reverse shell file to the TFTP server, then set up a local netcat listener, then trigger the reverse shell to get a connection back to us. I'll adjust this linked PHP reverse shell PHP file by replacing this IP line with my attacker IP address, and I leave this port as is. Then after I upload the customized reverse shell file to the TFTP server, I'll try to trigger it by navigating to the default root directory where files are stored on TFTP server, and that is var lib tftp boot, as seen on this TFTP page. This time I'll trigger the execution from the terminal, not as usual from web browser. And with that we expect our netcat listener will catch the connection. We will not receive a shell that is fully interactive, and we will make it a bit better by using this Python 3 command. Python 3-c import pty spawn bin bash. I'll now pause with reading the walkthrough and do the hands-on tasks until this lateral movement section. I should have the default version of this pentest monkey PHP reverse shell file already available on my attacker instance. I'll copy paste it to my included directory for this starting point machine and adjust the IP. And let's first try to locate it on my attacker machine. I'll copy paste it from here, user share, web shells, PHP, PHP reverse shell, PHP. So copy from there to current working directory. Then let's adjust the IP role. Let's upload the file and set up local netcat listener. Also, to follow the official walkthrough as close as possible, let's rename this file to shell.php. I didn't get here any confirmation about file being successfully uploaded, though let's try it out. Let's quit from here and let's try to refer to the file after setting up local netcat listener. Let's do that from the new tab. And let's adjust this command. Great, we have a connection back, so let's stabilize our shell. Great, we are now www data user. To save us time, I'll mention that we would after a while conclude that we do not have enough privileges to read the user flag. Therefore, we need to find a way to move laterally to user mic, was also found listed in the passwd file. A good place to start this enumeration would be the web server directory, as it often contains configuration files that might include passwords. The web-related files are usually stored in the var www.html folder, so we'll proceed to switch to it. And to show relevant documentation for this part in the web browser, in our initial nmap output for TCP scan, we notice the version of web server. Here we see also Apache, and in documentation for Apache and the website content section, we notice var www.html mentioned. Here we can observe two interesting files, htaccess and htpasswd. Let's proceed to read both of these hidden files. Great, we found password for user mic. And let's try to switch to user mic from our current user www data using this password. Great, that worked. And let's locate the user flag. It's usually in user's home directory, but let's try to get that information with find, for example. Find /-name user.txt. You see there's a lot of permission denied. Though at the top there is home mic user.txt mentioned, so we would proceed to cat out its contents to answer one of the test questions related to user flag. Great, catting out user.txt file will work. Now let's try to escalate our privileges to root and get the contents of root flag. First, let's look at groups the user mic is a member of. Notice that mic is a member of LXD group. And LXD is a management API for dealing with LXC containers on Linux system. It will perform tasks for any members of the local LXD group. It does not make an effort to match the permissions of the calling user to the function it is asked to perform. And we can find out more about LXD in this Hacking Articles LXD Privilege Escalation article. I'll navigate to this documentation in a minute. And another snippet of relevant explanation is that a member of the local LXD group can instantly escalate the privileges to root on the host operating system. This is irrespective of whether that user has been granted sudo rights and does not require them to enter their password. The vulnerability exists even with the LXD snap package. This hack tricks page describes the whole exploitation process step by step. The exploit works by making use of the Alpine image, which is a lightweight Linux distribution based on BusyBox. After this distribution is downloaded and built locally, an HTTP server is used to upload it to the remote system. The image is then imported into LXD, and it is used to mount the host file system with root privileges. Moving forward, there are two approaches to this privilege escalation. First one is to build the image locally, and that can be tedious due to dependency errors and other challenges. And I'll go down the option B using simplified process and download the pre-built Alpine image from the official LXC containers repository. I'll download the default Alpine 318 image for the AMD 64 architecture matching the target machine's architecture. Specifically, I'll download the two required files, lxd tar xz and rootfs squashfs. I'll skip this part of the walkthrough covering option A to build the image locally, and proceed from here when I download these two files. So let's pause with the walkthrough here. Let's navigate through relevant docs and download these two files. So relevant web pages for this privilege escalation section are this one, Linux privilege escalation module on Hack the Box Academy, that covers LXD, then LXD privilege escalation article on hacking articles, then this LXD LXC group privilege escalation page on Hacktricks. So we'll download these two files for Alpine 318 version and proceed from here. And lastly, the official LXD images page. We'll use lightweight Alpine 318 and let's verify target machine's architecture. And let's proceed with AMD 64 default one. And download lxd tar xz and rootfs squashfs. Let's verify the files are downloaded and then start the Python server on port 8000. With that, we'll transfer these two files to our target instance. And let's copy paste these two commands adjusted for our specific attacker IP address. And let's download these two files to Mike's home directory. Also, let's verify we have access to LXC command line tool and let's check out its help. Now let's create an image out of these two files and give it a name Alpine. Before that, let's check current LXC image list. There are no images at the moment available. Now let's run this command. And let's rerun LXC image list. Great, now we see Alpine. So Alpine is correctly shown in the image list. We now must set the security privileged flag to true so that the container has all of the privileges that the root file system has. We will also mount the root file system of the host onto the mount folder on the container. I'll copy paste first this command that will create previous container from Alpine image with one adjustment. Security privileged option will be set to true. Okay, so far so good. And let's copy paste the second command that adds to previous container this device host root disk, which essentially replicates contents of root file system of the host to mount root folder on the container. Great, so far so good. And finally, let's start the container and start a root shell inside it. Usually we can find the root flag in root's home directory, that would be /root, and replicate it to our container, that would be /mount/root, then /root. So let's navigate to that subdirectory. Let's list its contents. Great, and lastly for this hands-on section, let's get out the root.txt. Let's go over these tasks questions. Task number 1, what service is running on the target machine over UDP? That's TFTP. Task 2, what class of vulnerability is the web page that is hosted on port 80 vulnerable to? That's local file inclusion. Task 3, what is the default system folder that TFTP uses to store files? That's the default one we saw in the manual. Task 4, which interesting file is located in the web server folder and can be used for lateral movement? And that's hidden file HTPasswd, where we found Mike's password. Task 5, what is the group that user Mike is a part of and can be exploited for privilege escalation? That's LXD. Task 6, when using an image to exploit a system via containers, we look for a very small distribution. Our favorite for this task is named after mountains. What is that distribution name? We used Alpine. Task 7, what flag do we need to set to the container so that it has root privileges on the host system? And that was security privileged equals true. Task 8, if the root file system is mounted at /mnt in the container, where can the root flag be found on the container after the host system is mounted? So that would be /mnt/root/. And after submitting contents of user.txt and root.txt, we can say we completed the box and we can terminate this included target instance. And that would be all for this video. Like and subscribe if you enjoyed this one. Until next video, bye for now.